Cornell from Cornell Engineers. Welcome to your Saturday morning, and today we're doing a by request quick chat about retaining walls, zone of influence, where you can build, how close you can build to a retaining wall, and we've actually gone back to the old style because you're going to need to see my hands, the old style of overhead camera. So welcome aboard. Let's talk about retaining walls. Retaining walls, as we all probably know, are used to hold up the dirt on one side to create a flat side or a flatter side on one side, a high side and a low side. In Queensland, the ownership of a retaining wall comes down to who the retaining wall was built to benefit. We're not getting into that so much today because that gets very complicated, especially when you're talking about old retaining walls. But let's talk about zone of influence and how close the questions that Rob Dontis actually raised for us were. Retaining wall, angle of repose, and zone of influence, how close can you build to a retaining wall? So let's just cut to the overhead and let's have a little chat about this. Okay, so retaining walls, like we said, are typically walls. Sometimes they're vertical, sometimes they're less vertical or built into the slope a little bit, but in this case, we'll show the lower ground on this side, we'll show the high ground on this side, and this here is our retaining wall. It's holding the dirt, stopping it flowing down onto the low side. So when we're talking about angle of repose, I'm going to need another piece of paper already. Angle of repose, that's the angle you get when soil gets dumped in a pile and it sort of settles down under its own weight. And the more you build it up, it still keeps that same shape. That's important to us because it's the soil that lands on top of that angle of repose that actually helps put load on our retaining wall. So if our retaining wall was built here, it's this soil above that line that is actually putting a horizontal force onto our retaining wall. As engineers, we look at this force from the soil in two ways. It's sort of like a hydraulic load, like a water load, that the higher the wall gets, the bigger the load gets at the bottom, and the load actually gets smaller towards the top, and we show it as a triangular load as engineers. When we're designing a retaining wall, we're more interested in the overall forces on the retaining wall and how it's resisted, whether there's a concrete slab underneath or a deep footing built into the ground, or is it well, that was the sleeper retaining wall with the deep footing built into the ground, or the concrete slab is what we'd normally use for like a concrete masonry retaining wall. There's also timber retaining walls, which are a bit like the sleeper retaining wall with the deep footing built into the ground. But this wall is essentially just holding back that soil that is above that angle of repose. The angle of repose changes when the soil gets wet. So you remember the last time you went to the beach and you built a sand castle? Here we go. Sand castle sitting on the beach, and straight out of the bucket, the sand stays up nice, wet sand stays up nice and straight. As soon as you pour some water on it, it slumps. So imagine you did that to the water that's behind your retaining wall and you poured water down here in behind the retaining wall. Now that soil does the same thing as it does, the water does the same thing to the soil behind the retaining wall, unless it's rock, as it does to the sand on the beach. It makes it slump. So when we talk about retaining walls, we talk a lot about drainage. We talk about the force of the soil on the retaining wall that we're designing as a structure, but we're also talking about it as a drained soil. We don't want water building up behind the retaining wall because that extra water, apart from the fact that it can also put load on the retaining wall itself, also makes the soil slump a lot quicker, puts a lot more load on the retaining wall. If we had the choice, we're going to design a retaining wall to be as economical as possible. So we include drainage, a layer of rocks or filter material that lets the water out of the soil so that the soil is free draining and the angle of repose is nice and vertical. So angle of repose for a wet soil would be down here, and there's a lot more weight all being applied to the retaining wall now. So that's angle of repose. That's the zone of influence isn't really covered there. Let's talk about back to this original page, our nice neat retaining wall diagram. Our zone of influence is more about when we have a structure or someone standing on top of the wall or someone driving on top of the wall on the high side of the wall. How close can they be to that wall without it putting load on the wall? Or alternatively, if it's close to the wall, how much of that load actually gets transmitted into the wall and has to be designed by the engineer with the footing and the strength of the wall itself, the strength of the steel posts. If it's a concrete sleeper retaining wall with steel posts and concrete sleepers between it, how much of that load has to be covered by the retaining wall? Ideally, the further you put the load away, the better. The angle of repose tells us that anything within that line of soil where we're already talking about that soil on top, beg your pardon, that soil on top of that angle of repose is already putting load onto the retaining wall, has to be designed for it. That extra weight from the people and the cars and the buildings on top of the retaining wall also apply a load to that soil, and it might look like they would just be pushing down, but because the way the soil works, that load also translates into a horizontal load on our retaining wall. So now we've got how far, the answer to how far away does something have to be before it no longer applies load onto the retaining wall becomes a little bit more simple when we understand about this zone of influence line. If it was, say, a 45-degree line, a 1-in-1 line, and the wall was 1.8 meters high, that angle or that line of soil that's affected that puts load onto the retaining wall is obviously 1-in-1, 1.8 meters. So if you've got a 1.8 meter high retaining wall and you're closer than 1.8 meters with your building or your vehicles or your big heavy people walking across the top of the retaining wall, those loads are being resisted by the retaining wall. If you're further away than that line, if it's a 45-degree line, which is our basic starting point, if we don't have any idea what we should use, we'll assume it's a clay and we'll assume about a 45-degree line. If you've got nothing in that zone, then we're still going to design your retaining wall for that surcharge load, because you can't, unless you can actually stop someone building there or can stop someone driving there or someone walking across the top, we're going to have to allow for it in our design as structural engineers. So we allow maybe 5 kPa, 500 kilograms a square meter, if someone can drive on that high side of the wall. A little bit less if someone can, if it's only a footpath, it might be 200 kilograms a square meter, which is still a fair bit. And that's the extra load on top of the weight of the soil being applied to the design of the retaining wall. So we, I think, have just about covered all the questions we had from Rob Dontis. How close, retaining wall angle of repose we've covered, zone of influence we've covered, and how close can you build to a retaining wall we've covered. In theory, you can build on top of a retaining wall, don't forget, but it just means that the engineer has to take that into account when they do their design. I'm Matt Cornell from Cornell Engineers. I hope this has been useful. Stay tuned. We'll have some more live streams every now and then. You know what? There's a lot less editing involved in setting up a couple of cameras and having a chat to you live than there is when I do all sorts of stuff and record it and multiple cameras and put it all together. This is way easier for me. So if you like this and you've got a couple of questions that you'd like me to answer in the next live streams or in future live streams, let me know. That'll give me a chance to have a think about what we're going to say. We'll roll the camera and I'll answer your questions. I'm Matt Cornell from Cornell Engineers in Queensland, Australia. Hope you have a good weekend. I'll catch you later.